In today's lesson, I can write equations of quadratic functions using vertices, points, and x-intercepts. I can write quadratic equations to model data sets, and I can solve real-life problems. For the warm-up, we're going to be finding the slope-intercept form of a line that has a slope of 2 and passes through the point 5, 7. There's actually two ways to do this. Because we're given the slope and a point that is on the line, the first way that you could approach this problem is to use point-slope formula. Let's go ahead and just review the different types of forms we have for linear equations. Okay, I know to use a linear equation because it talks about it being a line in the problem. For linear functions, slope-intercept form is y equals mx plus b, where m represents the slope and b represents the y-intercept. If I want to write the y-intercept as an ordered pair, it would be 0, b in this case. For a point-slope form, that is y minus y1 equals m x minus x1, where m, again, represents the slope, and x1, y1 represents any point on the line. Okay, so in this problem, because we're given a slope and a point, I would use point-slope form, okay? Because again, we're given a slope and a point. So I'm going to write y minus y1 equals m x minus x1, and I'm going to plug in the different components that we see here. Let's go ahead and label 5, 7 as my x1, y1, so I know where to plug it in. Y minus y1, y1 is 7, equals m is 2, x minus x1 is 5. Okay. Then we use the distributive property to help us simplify. We get y minus 7 equals 2x minus 10. And if I add 7 to both sides, we end up with, for our final simplified form of that equation, we get y equals 2x minus 3. Now that's one way I could solve it. I can use slope-intercept form as well. Let me show you how I would go about doing that. Y equals mx plus b. In this case, again, m is 2. And remember, 5, 7 is not the y-intercept, but it is a point that's on the line. I know it's not a y-intercept because remember, y-intercepts are written as 0, some number. Okay, and that's not what we see here. So I can't say that 5, 7 is my b value, but it is a point on the line. So I'm going to label this xy. Here's another way you can go about this. Plug in 2 for m, plug in 5 for x, and plug in 7 for y. So it's y equals, or 7 equals, m, which is 2, x. Instead of writing x, what would I replace x with? X was 5 plus b. And I can use this to solve for what b is equal to. 7 equals 10 plus b. If I subtract 10 on both sides, I get that b is negative 3. And so now when I rewrite my original form, remember m was 2, and then we just got that b was equal to negative 3. So instead of mx plus b, I would write 2x minus 3. You can see how I get the same answer either way I go about that problem. All right. We just reviewed the linear forms. Now let's review different ways you can write a quadratic function. The first way is vertex form. This is my favorite because you can clearly see the transformations. You can clearly see the vertical reflection, vertical stretch or shrink, horizontal stretch or shrink, left-right shift, and up-down shift for your parabola. Most of the real-world graphs that we're going to work with don't have a horizontal stretch or shrink, so if the b value is equal to 1, right, if the b value is equal to 1, another common way that you could write this is y equals a x minus h squared plus k. That's also known as vertex form, where the vertex is h comma k, and x and y represent any point Let me go ahead and rewrite that. Any point on the curve or on the parabola. The next form we can talk about is intercept form. In this case, the x-intercepts are p and q. If I wanted to write those as ordered pairs, it would be p comma 0 and q comma 0 for x-intercepts. xy, again, is any point on the curve or on the parabola, the U-shaped graph. And the last type of quadratic form is standard form. I think this is my least favorite just because we can't understand where the x-intercepts are, or we don't know what the transformations are, right? Can't really understand the left, right, or up, down shift of the vertex. Again, the a value still does represent the vertical stretch or shrink, and a negative out front would still indicate a vertical reflection. The b value in standard form has a different meaning than the b value in vertex form. Notice there's no h in standard form, so it's difficult to understand the left-right shift of the vertex. We already discussed how to find the x-coordinate of the vertex for a standard form quadratic function in lesson 5. Remember, if I want to find the x-coordinate, I would use negative b over 2a. The c value represents the y-intercept, so we would express that as 0 comma c. Notice there's no k value, so that means that the c value is not the y value of the vertex. We already discussed how to find the y-coordinate of the vertex for a standard form quadratic function in lesson 5. So if you don't remember how to do that, you can go back and rewatch that video. Once I get that the x value is negative b over 2a, to get the y-coordinate, I would just plug the x value back into your function in order to get the y output. Okay, so we would say that the vertex is negative b over 2a, comma f of negative b over 2a. xy, again, is any point on the parabola or on the U-shaped graph. Okay. So now that we've taken time to review those different forms, we're going to focus on writing quadratic equations today. If we're given a point xy and a vertex hk, I would recommend using vertex form. Okay, so again, if you're given the vertex, use vertex form. If I'm given a point xy and the x-intercepts p and q, then we're going to use intercept form. Again, if I'm given the x-intercepts, then I use intercept form. Now, what do we do if we're given 3 points? If we're given 3 points, we're going to write and solve a system of 3 variables like we did in Unit 1. So that's going to be definitely the most time-consuming. We definitely prefer to have a vertex or x-intercept given to us just because solving a system with 3 variables is going to take a little bit longer. All right, let's go ahead and take a look at example 1. It says writing an equation using a vertex and a point. For this example, because we're using a vertex and a point, which method do you think we would use? Would we use vertex form, use intercept form, or solve a system of equations? Well, because I'm given a vertex, I'm going to be using vertex form for this example. So let's just keep that in mind. The graph here shows a parabolic path of a performer who is shot out of a cannon, where y is the height in feet and x is the horizontal distance traveled in feet. Write an equation of the parabola. The performer lands in a net 90 feet from the cannon. What is the height of the net? So we have 2 different questions going on here. We have to first write the equation of the parabola, and then we have to answer what is the height of the net. So I'm going to divide this space into 2 parts so that I can make sure I have enough room for each part of the problem. Let's start with writing the equation of the parabola. Remember, the vertex is the highest or lowest point on the curve. So in this case, this curve has a high point right here, and that is 50, 35. So I'm going to use that as my vertex h comma k. So let's just make a note of that. The vertex is h comma k, and in this case, it is 50, 35. Okay. In order to use vertex form, I not only need the vertex, but I also need a given point. So what's a point that we could use? Let's use 0, 15 as a point, xy. Okay. I could use this point, but I wouldn't recommend it just because you're going to be approximating. See how you really don't know what that y value is? It's better to use a point that's given to you than to approximate the point. All right. I'm also going to write in my vertex form just so I know where to plug in each one of those variables. Okay, let me zoom in. So I've got h is equal to 50, I've got k is equal to 35, I know that x is equal to 0, and I have that y is equivalent to 15. Let me write my vertex form. Y equals a, x minus h squared plus k. Again, I know to use vertex form because I was given the vertex. And I'm just going to start plugging everything in. What was y equal to? Y was equal to 15. Do I have something to replace a with? No, so I'm just going to leave it a. What's x equal to? X was equal to 0, right? So I plug that in, minus h. H is 50, plus k, and k was 35. Okay, so you can see that I've got a that's left over here. What we're going to do is solve for a, so I know what to replace a with in the original equation. It's similar to what we did up here when we were working with linear form, right? Do you see how when we were working with linear form, we started our equation off where we plugged in everything except for b? And then what we did is we ended up solving for b. Once we got what b is equal to, then I knew what to replace b with in my original form. This idea is no different than what we're doing with quadratic functions. Okay, we're going to follow that same format. Let's go ahead and solve for a here. I'll have 15 equals a. I'm going to simplify what's inside the parentheses. Okay. Now, as far as order of operations, we're thinking PEMDAS, so I want to make sure I simplify any exponents before I do multiplication. Let me go ahead and square negative 50. If you're typing this into your calculator, make sure you put parentheses around negative 50. When you multiply negative 50 times negative 50, you should get a positive 2,500. All right, again, if you're squaring negative 50, you got to put parentheses around it in your calculator. All right, now I'm trying to get a by itself. I'm not simplifying anymore. I'm just trying to solve for a. So when I'm solving for a, I'm almost going to use order of operations in the reverse order. Since I'm trying to undo the operations, I'm going to undo any addition or subtraction before I undo the multiplication or division here. So I'm going to undo the plus 35 first by subtracting 35 from both sides. That's going to give me negative 20. And a times 2,500 is 2,500a. Now to undo that multiplication, I would use division. And a is going to be equivalent to, let's see, negative 20 divided by 2,500, and my calculator gives me negative 0.008. Now that decimal's okay because I didn't round that at all. You never want to round anything. You want exact answers. If I hit math and then press enter on frac by math bracket, you could also write a as negative 1 over 125. That would be another acceptable answer. So either one. Now that I know what a is, I'm going to go ahead and rewrite my original function. Remember, my original function looked like this. Y equals a, x minus h squared plus k. All right. When you rewrite your original function, you want to replace a, you want to replace h, and you want to replace k with what they're equal to. And we're going to keep x and y just as variables. Okay. So my function now is going to look like this. Y equals a we got was negative 0.008. X minus h. H was 50. Plus k. And what was k? K was 35. And that would be your answer for part A, where it wants us to write the equation of the parabola. Okay, now that we have the equation of the parabola, we can talk about part B. It says, what is the height of the net? It says that the performer lands in a net 90 feet from the cannon. What is the height of the net? So keep in mind the x-axis here represents horizontal distance, where the y-axis is going to represent the height in feet of the net. So again, my x value is the distance, where the y value is the height of the net. So let's just read that one more time. It says the performer lands in a net 90 feet from the cannon, which that's going to be your horizontal distance, x, and it says what is the height of the net? And so we're looking for the y value. We're given the x value. We're given that x is equal to 90, and we're looking for what the y value is. So again, just look at that point. This point right here is 90, comma, and we didn't know what that y value was. Remember how before we talked about how we would have to approximate that y value? Like just looking at that, what do you think the y value could be? This is 20, 25, 30. It looks like it goes up by 5s. So maybe like 22 or 23 might be the height of the net if I was just approximating. But let's use our equation from part A in order to get the exact answer. So I'm going to rewrite my equation. Y equals negative 0.008 x minus 50 squared plus 35. And now I know what x equals. Okay, well again, my goal is I'm going to plug in x, and I'm going to solve for y, which will represent the net height. So I have y equals negative 0.008, x was 90. Okay, put the minus 50 and then square it, plus 35, and we're going to simplify this expression. PEMDAS, we simplify what's in the parentheses first. So 90 minus 50 will give me 40. Again, PEMDAS, after parentheses comes exponent, so I'm going to do the 40 squared. That's 1600. Whoops. All right. So I'm just going to write this off to the side. We simplified the parentheses, we simplified the exponents. Now I've got to do the multiplication, so I'm going to do this part since I'm simplifying. Y equals, we're going to multiply that 1600 by negative 0.008, and we get negative 12.8. And finally, we can do our addition, the plus 35, which is going to be 22.2. Okay, again, that represents the net height. Height is represented in feet, so I'm going to say that the net is 22.2 feet off the ground. Okay. Student practice. It says, write an equation of the parabola that passes through the point negative 1, 2 and has a vertex of 4, negative 9. Again, as soon as I see the word vertex, I know that I'm going to be working in vertex form. So I'm going to write down this vertex form. It tells me that my point is negative 1, 2. My point is xy, and my vertex, remember the vertex we represent with hk. So I know that x is equal to negative 1, y is equal to 2. We know that h is equal to 4, and k is equal to -9. And we're going to plug in each one of those components. So what is y equal to? Y is equal to 2. A, we don't know. X is equal to -1. H is equal to 4. K is equal to -9. Okay, so we'll have 2 equals A. Simplify what's in the parentheses, that'd be -5. And instead of putting plus a -9, I'm just going to put -9. Okay, again, with PEMDAS, when we're simplifying, we want to simplify the exponent before any multiplication. So I'll get 2 equals A times, that's going to be 25. Remember, whenever you're squaring a expression, it should become positive. So -5 times -5 would be a positive 25. All right, let's go ahead and write this as 25A minus 9, right? A times 25 is just 25A. And now that we have simplified everything that we can on either side of the parentheses, now that we have simplified everything we can on either side of the equal sign, now we're going to start moving things to different sides of the equal sign. So rather than working with PEMDAS in this direction, which is what we use to simplify an expression, we're going to be using inverse operations here to move things to different sides of the equal sign. So I'm going to undo any addition or subtraction before I undo any multiplication or division. So I'm going to undo the -9 first by adding 9 to both sides. All right, and then I'm going to undo the multiplication by 25, and I'm going to divide both sides by 25. So I end up getting 11 over 25 for A. If I put 11 over 25 in my calculator, I get 0.44. That is a terminal decimal that stops. It's not like we rounded that, so you can choose to use either one for A. I'll go ahead and use 11 over 25. Okay, so I'm going to borrow this equation again. And when I'm writing my final answer for the equation of the parabola, I want to make sure that I replace A, H, and K, and I want to leave X and Y just as X and Y. So I'm going to write my final answer as Y equals, A was 11 over 25, X minus H, H was, let's see, 4, and K was -9. So instead of putting plus a -9, I'm just going to put -9. And I love vertex form because I can clearly see the vertical shrink, right? It's a number less than 1. I can see the right 4 down 9. Okay, so my vertex here would have been at 4, -9, which is what we started with. All right. Example 2, it says writing an equation using a point and an x-intercept. So now I'm given a point and an x-intercept. So let's think about what equation I would use for a point and an x-intercept. I'm going to be using intercept form. So I'm going to grab this equation and copy it down. A, x minus p, x minus q. Y equals A, x minus p, x minus q. All right, this one says a meteorologist creates a parabola to predict the temperature tomorrow, where x is the number of hours after midnight and y is the temperature in degrees Celsius. A, write a function f that models the temperature over time. B, what is the coldest temperature? So again, we're going to be doing two different things. In this example, we first need to find the equation, but I'm going to make sure that I keep some room here, so I'm going to just split it down this way. So we'll use this side for part A, and then we'll use this side right here, and then we'll solve part B in that space over there. All right, let's take a look at our picture here just to find the point and the x-intercepts. right. X-intercepts is where it crosses the x-axis. So the x-axis is your horizontal axis right here. So where does the parabola cross the x-axis? Looks like it crosses, let me go ahead and rather than highlighting it, I'm going to draw it. Looks like it crosses the x-axis right here and right here. So these are our x-intercepts. This is our p, 0 and our q, 0. Remember, x-intercepts are p and q. In order to use intercept form, we also need another just random point on the curve. You can pick any point you want on the curve, but I like this point because it's already labeled for us. So that's going to be my x, y. I'm going to rewrite that over here. I've got, just move this down a little bit. I've got that xy is 0, 9.6. I've got that my first x-intercept is 0, and I've got that my second x-intercept is 0. So we're going to say x is 0, y is 9.6, p is 4, 0 is just 0, q is 24, and again I don't need to write that 0 is 0. All right, let's plug in those components and try to simplify. So what's y equals? That would be 9.6 equals a. I don't have anything for a yet. X is 0, minus p was 4. Then we have x again. So again, we're going to put 0 minus q, and q was 24. All right. So I plugged in everything. Again, a is chilling out front. We need to solve for a so that I can rewrite my equation later. We get 9.6 equals a. 0 minus 4 is negative 4, and 0 minus 24 is negative 24. All right, let's go ahead and multiply these together. Negative 4 times negative 24 is equivalent to 96. So I'm going to write this as 9.6 equals 96a, and then to get a by itself, we divide both sides by 96. A is equal to what? What is 9.6 divided by 96? That is 0.1. Okay. Another way that you can write 0.1 if you math bracket is 1/10. Either option would be acceptable. Right? Let's just use the decimal form since this is a real world example problem. And now I'm going to rewrite this original function here. Okay, again, the original equation was y equals a, x minus p, x minus q. When we're rewriting it, we're going to replace a, p, and q with constants, but we're going to keep x and y as variables. Very similar to what we did in the last example with vertex form. So my final answer is going to be y equals, we got that a was 0.1, x minus p, p was 4, and x minus q, q was 24. All right, and that's what we're going to use for our equation. All right, now we can look at part B. What is the coldest temperature? Let's take a look at our axes. Just look at the labels so we can interpret the graph a little bit better. Remember, the x-axis is going to represent the hours after midnight, so that's the time, where the y-axis right here represents the temperature. So when it asks what is the coldest temperature, we're looking for the lowest y value. So where on our graph do we see the lowest y value? Well, it's down here somewhere, right? It's going to be at the vertex. That is what represents the lowest point on the graph. And right now, I don't know what the vertex is. How could I find the x value of the vertex if I'm given both of these x-intercepts at 4 and 24? Remember, the vertex lies on the axis of symmetry, so how could I use the x-intercepts in order to get this axis of symmetry right here? Well, if there's symmetry, that means that the x-intercepts are both equal distance away from the axis of symmetry. So what number is right in between 4 and 24? If you're not sure, the fastest way to get the number that's right in the middle of 4 and 24 is to average 4 and 24. I'm going to add those numbers together and divide them by 2. Make sure on your calculator you're either typing it in where the 4 plus 24 is in parentheses if you're going to do it all at one time. Or another thing you could do in your calculator is do 4 plus 24, press enter, and then divide by 2. All right, but you got to be careful with order of operations in your calculator. When you do that, we end up getting that the x value is 14. Remember, the vertex lies on the axis of symmetry, so that means that the vertex has an x value that's equal to 14. And I need to know what the y value is of that vertex. All right, so I'm going to plug in an x value of 14 into this equation that we got. Y equals 0.1. Again, instead of x this time, I'm going to replace it with 14. And again, instead of x, we'll replace it with 14. And you can see if I simplify this side of the equal sign, I'll get the y output. So when x is 14, what is y? Well, let's simplify that. We get 0.1 times 10 times negative 10. And if I multiply all of those components together, 0.1 times 10 times negative 10, I get a y output of negative 10. Okay, so negative 10 degrees is going to be the lowest temperature. And again, that would be the y value of the vertex, or the lowest point on your graph. Last one, write an equation of a parabola that passes through 2, 5 and has x-intercepts at negative 2 and 4. So again, I'm given x-intercepts, so I'm going to use x-intercept form. We're given the point 2, 5. That's going to be just our random point, xy, that's on the curve. And then negative 2 we'll call p, and 4 we'll call q. So when I'm setting up this equation, y equals a, x minus p, x minus q, I'm going to be plugging in 2 for x, 5 for y, p is going to be negative 2, and q is going to be 4. So we'll have y equals, will be 5 equals a, x is 2, minus p, p is negative 2, so be careful with your signs here. We just have 2 minus a negative 2. X again is 2, and q is 4. So we'll get 5 equals a. That's going to simplify to 4, and this will be negative 2. If I multiply that together, we end up getting negative 8a. And to get a by itself, we divide both sides by negative 8, and we end up with negative 5/8 for a. I don't like to leave a negative sign in the denominator, so I'm going to write negative 5/8 like this instead. Let's go ahead and rewrite our equation now. Again, when I rewrite my equation, we want to leave x and y as variables. So I'll replace a with the negative 5/8. I'll go ahead and replace p with the negative 2. And I'll replace q with the negative 4. And let's correct that minus a negative. We get x plus 2 and x minus 4. Okay, and that's it.